CNC, short for Computer Numerical Control, is a technology used to automate and control machine tools through the application of microcomputers attached to the tools. CNC machines operate based on coded programmed instructions, determining movements, material feed rates, speeds, and more. The need for manual control by operators is eliminated, significantly enhancing efficiency and precision. From its initial development in the 1940s to 2022, CNC technology has continuously evolved and become a crucial component in various industries. In this blog, we'll delve into the workings of CNC different machining processes, its advantages, and more. Let's explore further. How CNC works. In a CNC system, microcomputers execute basic functions according to the loaded program in the machine control unit. These programs send commands to the servo drive, enabling functions like motor and coolant control, tool changes, and pallet shifts. Continuous monitoring through feedback devices ensures precision, and in case of errors, the system generates a fault message to alert operators. Types of CNC machines. CNC mills, typically featuring a 3-axis system, X, Y, Z. CNC mills can run programs with numeric and letter-based prompts, guiding workpieces through different distances. Both G-code and unique languages developed by manufacturing teams can be used for programming. CNC lathes, performing high-precision, high-speed cutting in a circular direction. CNC lathes use indexable tools. Controlled by G-code or other unique code, lathes consist of 2 axes, X and Z, and are suitable for manufacturing intricate products. Plasma cutters, primarily used for cutting metal materials. CNC plasma cutters employ compressed air gas and electrical arcs to generate plasma, providing the speed and heat needed for metal cutting. CNC electric discharge machines, utilizing electrical sparks. Electric discharge machining, EDM, molds workpieces into specific shapes. Continuous electrical discharges between 2 electrodes remove unwanted materials. CNC laser cutter, similar to plasma cutters, CNC laser cutters work on various materials like metals, plastic, or hardwood. Laser intensity can be adjusted based on the material's density and strength. CNC router, controlled by computers. CNC routers cut a variety of materials such as steel, wood, aluminum, and plastic. Known for higher productivity and less waste, they offer efficient manufacturing. CNC machining. CNC machining accommodates various materials, making it popular in industries like automotive, medical, electronics, and telecommunications. The machining process involves several steps. Step 1. CAD model design. Create a 2D or 3D CAD model using computer-aided design software, including product dimensions and geometries. Step 2. File conversion. Convert the CAD file to a CNC-compatible format, usually G-code, using computer-aided manufacturing software. Step 3. Machine setting. Set up machines, ensuring proper speed, positioning, and tool attachment. Incorrect settings can damage machines and parts. Step 4. Machining operation execution. Machines execute commands from the program, strictly adhering to each movement. The final products match the original design. Common processes for CNC machining. CNC milling. Rotating multi-point cutting tools remove excess materials, ensuring high precision in part manufacturing. Suitable for rapid prototypes and finished components. CNC turning. Done on CNC lathes or turning centers. CNC turning combines rotary motion of workpieces and translatory motions of tools to remove unwanted materials. Advantages of CNC. High production efficiency. CNC machines work automatically, improving production efficiency with minimal manual intervention. Consistency and precision. Controlled by computers, CNC machines eliminate manual errors, ensuring consistent high-quality products. Cost effectiveness. Despite high initial costs, CNC machines prove cost-effective due to high productivity and lower manufacturing errors. Versatility. CNC is versatile, suitable for manufacturing parts of different shapes with high accuracy and quick turnaround time. CNC technology continues to gain popularity, revolutionizing manufacturing processes and reducing overall costs.